Greetings to everyone. Today we are going to design and demonstrate the working of TDM and recovery of two band limited signals of PAM. So let us start with our experiment. This is the simulation for our circuit designed in Multisim. So the apparatus we have used, the components we have used are the resistors, which you can see 1K resistors. We have used two transistors. The transistors which are supposed to be used in real experiment are SL100 and SK100, but for the sake of simulation we have used BC547B for the NPN transistor and BC557B for the PNP transistor. They have the same characteristics. We have used an op amp, and these are the waveform generators and an oscilloscope to check the output. So what is TDM? It is a method of transmitting and receiving independent signals over a common signal path by means of synchronized switches at each end of the transmission line so that each signal appears on the line only a fraction of time in an alternating pattern. It is generally used when the bitrate of the transmission medium exceeds that of the signal to be transmitted. In short, we can think of TDM as a multiplexer which switches in between its inputs and selects a particular input to be transmitted as the output over the carrier signal. Before going into the simulation, I would like to show you the real circuit which we have drawn. This is supposed to be the real circuit in which we use these SL100 and SK100 transistors. We would use a carrier wave of square 1.5 VPP 2 kHz frequency. We will use two message waves M1T and M2T. One would be a sine wave and the other would be a triangular wave of the same frequencies. Now let us jump into the simulation of the circuit. Now we will observe the oscilloscope which we have connected to the output of the op amp. We had to do some minor changes before we could show you the output of the circuit. So we have set the input. This is the carrier waveform for 2 kHz. This is the sinusoidal waveform which we explained earlier, the message. And this is the second message waveform which would be triangular. Now let us go to the output of the circuit. So yes, here we can see a PAM signal output. Now we would see the demultiplexer circuit. Before jumping on to the actual lab experiment, I would like to complete the electronic setup and the simulation. So I want you to show the demultiplexer circuit now. So this is our practical demultiplexer circuits. We're using the same two transistors and a couple of resistors, and we would get the message PAM outputs feeding the TDM input into this circuit. Coming back to Multisim, this is our demultiplexer circuit. We're feeding the op amp output to the circuit. We have used two transistors, the same two we used earlier, and now we are feeding the two message outputs which are PAM outputs into the oscilloscope. So let us simulate it and see what does it give us. So we can see from the oscilloscope output the M1 and M2 message output signals which are PAM signals. So these two are combined. So to see a clearer picture of each output, we would see one at a time. Let us see this one at a time. So this is the M1T, the PAM output, which is sinusoidal in nature. Now let us see the second one. Now let us see the second message output. This is the triangular wave, we can notice, with some small noise.
स्क्वायर वेव कैरियर स्क्वायर वेव के लिए ये अपना दो मैसेज सिग्नल्स है, एक साइन वेव एक ट्राइंगल वेव, और इसमें ये है अपना TDM आउटपुट, मॉड्यूलेटेड आउटपुट। और इसका पीक वैल्यू है यहाँ पे अपना पीक वैल्यू है 4.8 वोल्ट।